All right, today we're going to talk about the section 4.3. We're going to talk about the right angle theorem. Talk about finding one way to prove that two angles are right angles. And we talked about how to get triangles that are supplementary. We've been doing that by getting to have a straight angle first, and then we can say angles are supplementary. But if we can also say that those angles are congruent, so if we can get the angles are supplementary and congruent, then we can say that they are right angles, because we know that if they have to add up to 180 and then they are equal, so we can divide them by 2, we know that they would have to be 90 degrees. So our goal for today's lesson is to get angles that are supplementary and congruent. So a lot of what we've been doing in these proofs is going to be very similar and it's going to stay the same. If we're trying to prove that AD is the altitude of XS, we want to prove that this segment is the altitude. We know that prior to that, we're going to have to get that these two angles are right angles. And in order for that to happen, we are going to need to say that those angles are supplementary and congruent. So, basing off of our new terms, so we're going to need angles 1 and 2 are going to be needed to be proved supplementary and then congruent. So we're going to start with what we've been doing in a lot of our other proofs, which is first looking at the given, and we know that based off of our first given being the median, we know that we're going to be able to get congruent segments. We also know that because of the isosceles, we can get those segments are congruent. And then if we look here at the reflexives, so we have three different parts. We could say that the triangles are congruent, and we could go on with our normal path of getting those angles are congruent. We also already have a way of getting those angles supplementary because they are on a straight line. So, starting off with our first given information, we know that after we have a median, we can say that the segments are congruent. Using our median definition, if it's a median, then segment goes from the vertex to the opposite side, dividing it into two congruent segments. We then want to bring in our next given information, that we have an isosceles triangle, and then talk about what an isosceles triangle gives us. And although it was in parentheses, usually we'll have the isosceles, so we should probably list it separately. If a triangle is isosceles, then two legs are congruent. So far that gave us two of our sides. We're still missing a third piece of information, which is our reflexive step. And now we have our third side. We can now say that our triangles are congruent by side, side, side. And now we want to start bringing in what we talked about and how to get angles are right angles. First off, we're going to bring in that the angles are congruent. So that gave us our first step. So we've accomplished the congruent part. We then also want to talk about how to get the angles are supplementary. Well, first off, we're going to need to bring in that it's a straight angle. After we have it's a straight angle, we can say that the two angles that form the straight angle are supplementary. So now we have stated that the angles 1 and 2 are both congruent and supplementary. And if we can say that, then we can say that the angles are right angles. And putting the steps in parentheses, because steps 7 and 9 gave us the congruent and supplementary steps. And then our altitude definition tells us that if a segment goes from the vertex to the opposite side, forming right angles, then that segment is the altitude. Moving on to our next one. Similar concept with proving perpendicular. For proving perpendicular, we will also first need that those angles are right angles, so angles 1 and angles 2 again, to put in to make it a little easier. Same concept again, we're going to need two separate triangles. After we get the triangles, we can say corresponding angles, and then we can go with the supplementary route. So first off, if we talk about how we are going to get our triangles congruent, we have that the circle is given, but we don't have the sides necessary yet. So we're going to need to draw the two segments to form our triangles. Now, after they are drawn, we can say that they are congruent, because if it's a circle, then all radii are congruent. That gives us our first side. Our next given information will give us our next sides, because if it's a midpoint, then we know that it divides the side into two congruent segments. And then our third piece of information, similar to the last one, we have a reflexive step. So that gives us our three pieces of information to prove the triangles are congruent. So just like the last one, we have all three sides are congruent. So we can say the triangles are congruent by side, side, side. And now going back to what this lesson is about. So we want to prove perpendicular, which means we want to prove right. And in order to prove right, we need to first say congruent. And in this case, they're congruent by CT. So that gives us our congruent step. And then we also need to say that they are supplementary. So now we need to go back into our diagram and say that angle AMB is a straight angle. And angles 1 and 2 form that straight angle, so we can say that those two angles are supplementary. And that gives us our supplementary step. Now that angles are congruent and supplementary, we can say that they are right. And that was our new step. And then now we already have known that if two segments intersect forming right angles, then they are perpendicular. Would like you to go ahead and finish the third proof for tomorrow. Very similar to the last one in the sense that we are proving perpendicular, so we know prior we're going to need right angles, and prior to that we're going to need congruent and supplementary. So go ahead and finish proof number 3 for tomorrow, and that concludes section 4.3.